Assalamu alaikum warahmatullahi wabarakatuh. Welcome everybody. In this video, we are going to start with chapter 4, which is synchronous machine. In the previous chapter, actually, we have talked about the induction machines and we focus more on induction motors. And we said because 80% of the induction machines are used as motors and in the industrial applications. In this chapter, actually, we are going to start with synchronous machine, and our focus here will be more on induction generators because most of the synchronous machines are used as generators, not as the motors. We already know the difference between, or the main differences between the induction machines and synchronous machines, and we said in chapter 3, synchronous machines are machines whose magnetic field is supplied by a separate DC power source. That means the magnetic field of the synchronous machine is supplied from a DC power source or a separate DC power source, while the induction machines, their magnetic field actually is produced or supplied by the magnetic induction or the transformer actions where the current or the AC current is applied to the stator winding, it will induce magnetic flux rotating at synchronous speed, and this magnetic flux actually will cut or transfer to the rotor and cause the induction on the rotor windings. So this will cause either the machine to operate either as a generator or as a motor. So in this chapter, actually, our focus, as we said, on synchronous machines, and we are going to learn some of the concept or some of the topic related to the induction synchronous machine. Uh, the expected outcome of this chapter actually will be are listed here. Also, the reference that we are going to use in this chapter about the synchronous machine are listed under the reference category. These are the main topics that we are going to talk about it in this chapter. We start with the synchronous generators, and that we said our focus will be more on synchronous generator, while synchronous motor only we are going to go through them to have an overview about the synchronous motor. So in the synchronous generator here, we are going to talk about the construction of synchronous generator, principle of operation, equivalent circuit, power flow, synchronous generator operation, alone synchronous generator operation as in the or in parallel. Okay. Then we are going to have an overview about the synchronous motors. So the word here synchronous is come from the name syn and chronos. So it's equal time. It means at the same time. So synchronous machine are called synchronous here because their mechanical shaft speed and their rotating either the mechanical shaft and also the rotating magnetic flux, they have the same speed. In induction motor, we said the induction machine, it has two speeds. One we call it the synchronous speed, and one we call it the machine speed. So we said always I mean there is a difference between the synchronous speed and the machine speed, because the synchronous speed represent the speed of the magnetic flux generated in the stator windings, while the rotating or the machine speed represent the speed of the rotor of the machine. This was in induction machines. But in the synchronous machine, actually, the speed of the router, it is the same as the speed of the magnetic flux, which will be generated or supplied from the power supply. So the rotating air gap field here and the router rotate at the same speed. For that, we call them synchronous. So only in synchronous machine, we are going to see one speed, which is the synchronous speed that we learned before, which is ns equal to 120 f over number of poles. So the synchronous machine actually have field circuit which supplied by external DC source, and this we said the main difference between the synchronous machine and induction machines. So in the synchronous machine, we have a separate power supply or DC power supply which field the DC field winding. So the DC field winding here are replaced on the rotor. While in the case of induction machine, the field winding were placed on the stator winding or represented by the stator winding. So the field winding in this case, field winding of the synchronous machine, are placed on the router, while the armature winding are AC winding, which placed on the stator. This is the difference. So you can see in the induction machine, the field winding are the stator, the armature winding are the router. But in synchronous machine, the field winding are the router and the armature winding are the stator. Okay. So the synchronous machine are large machines. So in terms of the size, they are bigger than the induction machines, and also are primarily used as generator, as we already mentioned. So there is rarely applied or rarely used as the synchronous motors in some applications we are going to see later. So synchronous generator here, which is the main application of the synchronous machine, can be worked either alone or in parallel. So that means if we have synchronous generator, this synchronous generator can run alone, so it can feed some loads separately, individually, or it can be connected to interconnected system to the grid. So usually these synchronous generator are used in the power plant or power system, electrical power system, like power plants. For example, here TMB, they have a lot of mini power systems or mini power stations, and all these power stations usually use synchronous generators. So synchronous generator are machines which use to convert the mechanical energy into electrical energy, and this energy or electrical energy that we receive from the TMB here is generated by using synchronous generator. Okay, so usually if we have many synchronous generator, they are going to connect it together so they can supply bigger load, but also they still can running individually. So we can have one generator which supplies separate load. Like for example, if we have a power station placed in rural area or in the island, so it's no need to be connected to the grid, so it can feed some load based on the existing load in this island or in this village. Okay, the main features of the synchronous generator, it has a fixed speed and a fixed frequency and fixed voltage. So since it has a fixed synchronous speed, only one speed, fixed speed, so it has fixed frequency and it has also fixed voltage. Okay, the behavior of the in the case of, if we want to connect one synchronous generator to the grid, so this generator here, when it's connected to the grid, it should be synchronized with the frequency of the grid and also the voltage of the grid. So this generator, before we connect it to the infinite bus here, it should be it should have the same frequency and the same voltage of the grid. Otherwise it cannot be connected to the interconnected bus or into the grid. In term of, for the synchronous motor, actually they are built in a large unit. So synchronous motor, we said, it's just rarely used in some applications, and usually it's built in a large unit comparing with the induction motors. So induction motor, in the previous chapter we said, it has different rating, but it can be small units, while the synchronous motor are big units, and it used in several applications. Here we can see synchronous motor are used to regulate the voltage, so it used to improve the power factor of the grid. So usually if we have the power factor, lagging power factor for example, and very low power factor, which make a lot of losses in the electrical power system grid, so we can add or connect some synchronous motor at the end of the grid or at the end of the transmission lines to improve this power factor. When we improve the power factor, we are going to increase the value of P, since we know S, the apparent power, is equal to P plus minus JQ. So in the case of using the synchronous motor, we are going to improve the value of the Q, which is produced from the reactive or the with the leading power factor. So synchronous motor here are going to use to improve the power factor. So the value of Q, by supplying negative reactive power into the grid, for that it will improve uh, the voltage or the overall voltage of our grid. Okay. Second application of it, it can be used as a constant speed industrial drives. For example, for fans, for blowers, for DC generators, for centrifugal pumps and compressor and so on. So all such equipment or such machines require constant speed. So when we say constant speed, it's not suitable to use induction machine, because induction machine, the speed, as we see before, the speed of the induction machine start from zero, increase to n synchronous, then go to the if go more than n synchronous, it will go for to become induction generator and so on. But here in the case of synchronous machine, we only, or synchronous motor, the speed of synchronous motor is constant, so we can use it in some application which required a constant speed. So these are the main applications for the synchronous motor actually. Principle of operation. If we go to the principle of operation of the synchronous motor here, or synchronous generator, synchronous machine in general. So the synchronous generator or synchronous machine, we said the field is represented, or the field winding are placed on the rotor, while the armature winding are placed on the stator. So on the router here, on this part, on the rotating part, we have the field winding. On the rotating on the rotating part, we have the field winding, and here we have the armature winding. Armature field means the field which, or the winding which will generate the magnetic flux, and armature where the field or the winding which will produce you with the energy or with the power, in the case of synchronous generator. Okay, so usually the DC source or the DC current will be applied on the winding or in the conductor of the router. Okay, when the DC power goes through the conductor of the router, it will generate magnetic flux. When this magnetic flux is rotating by using a prime mover in the case of synchronous generator, so when this rotating, it will generate a rotating magnetic flux. This rotating magnetic flux will cut the router to the stator through the air gap. Okay, so when this magnetic flux reach to the stator windings, it will generate magnetic flux on the stator winding, which is the armature windings. Okay, then it will induce the voltage based on the Faraday's law that we learned in chapter 1 and chapter 2. In chapter 1. So it will generate in or induce a voltage in the router winding. So this conductor of the router here will receive or will have an induced voltage. So this induced voltage, when I connect it to the external circuit by using this two terminal here, it will send the current go through the circuit or through the load of this generator. Okay, so this is the main concept. The main concept is to start from a DC power source applied to the router winding, generate magnetic flux. Rotating magnetic flux will cut the stator winding and induce a voltage based on Faraday's law. This is in the case of the rotating or the synchronous generator. This is in the case of the synchronous generator. Okay. For the synchronous motor, the situation here a little bit different, because we have to, in the case of the motor, as we said before, it should have two magnetic flux. So in this case, in the case of synchronous motors, we have two magnetic flux, one on the router windings, which is produced by using the DC current or DC source, the other one on the and we call it the field winding actually, and the second one on the stator that we call it the armature winding. This come from an AC source. Okay, so the winding where the main voltage is induced over the stator windings here. So if we have magnetic flux on the router, magnetic flux on the stator, so it will generate a torque. This torque will make this machine to be rotating, so it will operate as a synchronous motor in this case. What is the difference between synchronous motor and induction motor? In the case of induction motor, the main field is on the stator. In the case of synchronous motor, the main field on the router. In the case of the synchronous and the induction motor, the armature is on the rotor. For the synchronous motor, the armature is on the stator windings. Okay, how is DC current applied to the router? We said in order to generate the field in the router winding, we need to use a DC current. And for that, this is one of the main differences between the induction and the synchronous machines. So how we are going to apply DC current to the rotor winding? We know the rotor, that means the rotating part of the machine. So how we are going to apply current or DC current to this rotor? Actually, there are two main methods. One is by applying a DC source. That means we are going to have a battery, for example, wire or connection from battery. It will be connected to these brushes, and on this process the current will go from we are going to connect it to the battery, for example, 12 volt or 24 volt, 120 volt, and so on. It's all DC, so the current will go through the brushes to the slip ring here, and it will go through the rotor windings or the field winding, and it will generate the magnetic flux. So this is one method. The second method actually is by using a DC power from a special DC power source. When you say special DC power source, we means we are going to use one exciter, or we call it brushless excitation system. Brushless excitation system will be placed on this area. So we have excitation system here, which will be coupled with the rotor, and this brushless excitation system will receive the power from AC source, convert it into a DC source, then it will feed it to the rotor field winding of the synchronous machine. As we can see here, this is how the brushless excitation system looks like, and this is the most common type of excitation of the synchronous machines. So we have two parts here. We have the exciter, and we have also here the synchronous machine. This is the machine that we have, and this is the excitation system that we have to that is coupled with the camshaft of the synchronous machine. So both of these machines are coupled together and rotating together. Okay, but this we call it the exciter, that one we call it the main machine or the synchronous generator or synchronous motor. Okay, so how this exciter got the input voltage? It will connect it to the three phase, from a three-phase supply here, three-phase power supply. It goes through the rectifier here. As you know that the rectifier is used to convert that AC to DC, so it will going to convert the AC to DC. So here the input to this rectifier is AC current, and the output will be a DC current. This DC current will go to the excitation of the field winding. This is field winding excitation. Okay, so this field winding here will generate magnetic flux. This magnetic flux will go to the fixed part of the exciter, and this one is the rotating part of the exciter. For that, the exciter or the rotating part will receive the magnetic flux. It will induce the voltage here. This voltage that will be induced in the rotating part will be AC voltage. It will go through another rectifier circuit here. The rectifier circuit will convert the AC induced voltage in the router of the exciter into a DC current that will be fed into the field winding or the router of the synchronous machine. So here, this is the main field or rotor of the main machine. This will be the stator of the main machine. This will be the stator of the exciter. This will be the rotor of the exciter. Rotor and stator, and here this will be the rotor, and this will be the exciter. Okay, so start AC, convert to DC, go to the field or to the stator winding, then convert into or generate or induce a voltage in the router. The induced voltage will be rectified by using a bridge or rectifier here. It will give you a DC current, which is the field current here, go through the windings of the router of the main machine, and the router of the main machine here will generate magnetic flux. This rotating magnetic flux will induce the voltage in the stator winding or in the armature winding, armature or stator, here field or router. Okay, so then these three field will be generate a voltage from the synchronous generator, and this is how the synchronous machine is operated, either by using brushless excitation system or by using a DC direct DC source system. We are going to continue in the next video.